Hello guys, and welcome to this tutorial on apply electrical science concepts. And we're going to look at the first topic, which is basic electrical quantities. So in here we shall be looking on basic units which are identified, such as power, current, and others. We shall also be looking at the quantities of charge, force, work, power, and we shall be performing some calculations in various electrical quantities. And the final bit is knowing the electrical laws that exist. So I shall do the first segment, which is introducing the basic electrical quantities and the calculations. And in the next tutorial, I shall be able to perform the electrical laws. So under this, we have some key definition of terms, which is a unit and an SI unit. So we always define a unit as that standard reference that is used to express or measure any physical quantity, and it can be used to quantify or compare the magnitude with different measurements. So for example, if you say that the unit of resistance is in ohms, then that ohm represents a standard value or a standard reference that can be used anytime we are dealing with resistance. Then you have SI unit, which is a globally recognized standard unit of measurement, and it's mostly applied for consistency in science and engineering. So for example, when you say the SI unit for current is amperes, so amperes forms as the SI unit. So those are the key definition of terms when it comes to that introduction bit. The next aspect we move is the basic unities or the basic unit. So a basic unit we always defined as a fundamental unit because it stands on its own. You cannot be able to do some further derivations onto it. So it is like it represents an independent physical quantity. So an example of those basic units are length, mass, time, electric current, and so on. From that table, you can be able to identify that we have quantities and we have a unit, whereby length is measured in meters, mass in kilograms, time in seconds, electric current in amperes. We have thermodynamic temperatures in Kelvin, luminous intensity in candela, then amount of substance in mole. So those are basic units. They are standalone units. They cannot be further converted. They exist on its own. Then you have derived units, which is a combination of both basic, and you can have two or more basic units combined together. So that forms a derived unit. We have velocity and acceleration being examples of derived units. So down there we have a table that has a prefix, a name, and a meaning. So from that table we can be able to identify a prefix, its meaning, and what it entails on it. So if you have capital M stands for mega, that is times 10 power 6 or times 1 million. Capital K stands for kilo, that is times 10 power 3. Small m stands for milli, that is times 10 power negative 3 or divide by 1000. Then you have that symbol that represents micro, times 10 power negative 6, nano times 10 power negative 9, pico times 10 power negative 12. So these prefixes will be mostly applied during the calculations because it will require you to do a conversion from one form to the other so that you can be able to put it into calculations and do the basics and get the final answer. So it means that you have to master the table because you'll carry it along during the entire course of the module. Next, we go to electrical quantities, whereby we define some electrical quantities here. One of them is charge. We always put the SI unit for charge as coulombs. We denote charge, which is denoted as capital C. Charge is denoted by Q. where 1 coulomb is 1 ampere second. That is the amount of electricity that is flowing past a given point when a current of 1 ampere is maintained for 1 second. That's how we define charge. So mathematically, it means that charge Q equals to IT. I standing for current in amperes, time standing for time in seconds, T standing for time in seconds. We have force is the SI unit is newtons, and it is defined as the force which is applied to a mass of 1 kg given its acceleration of 1 meter per second squared. So force mathematically is written as ma or mg, that is the mass in kgs times acceleration due to gravity. Then we have work, which is the SI unit for work is in joules, where 1 joule is 1 newton per meter. So we define it's the energy, the capacity to do work. So mathematically, work is force times the distance. So force being in newtons times the distance being in meters, you can be able to get the work done. Then power we defined as the rate of doing work or transferring energy. So this our unit for power is joules. And mathematically, we can represent power when given the work done or time, that is work done all over time. Then we have electrical EMF that is in volts. Then you have resistance and conductance, where resistance, it is the obstacle or opposition that is offered to the flow of current in a circuit. Remember that in any circuit, as it passes through a resistor, there is that opposition, because that is the main work of that component of the circuit. Then next we have conductance, the ability of a conductor to offer an easy path of current flow in a circuit. So mathematically, we represent conductance as 1 over R, that is the inverse of resistance. Then we have electrical power and energy, which is the product of voltage and current that is flowing in a circuit. So electrical energy is the rate of power being utilized by a load when a direct current is flowing in an electrical circuit. So mathematically, P equals to VI, which is voltage times current. Then electrical energy will be equal to power times time. So those are the definitions that we look at, and part B we look at the calculations. So the calculations here, we have, if a current of 5 amperes flows for 2 minutes, find the quantity of electricity transferred. So you'll have to recall that Q equals to IT from that formula. You have been given current as 2 amperes and time as 2 minutes. So converting the time into seconds and equating to that formula, which is Q equals to IT, then you find that 5 times 120 equals to 600 coulombs. So you'll have already gotten the charge, because the quantity of electricity transferred represents the charge. That is the definition of charge. And then we have a mass of 5,000 grams is accelerated at 2 meters per second by a force. Determine the force needed. So you'll recall that force equals to mass times acceleration. Mass being in kgs, acceleration you have been given from the question, acceleration is 2 meters per second. So you'll take 5 multiplied by 2, 5 kgs multiplied by 2 meters per second, it gives you 10 newtons. Then you have find the force acting vertically downwards on a mass of 200 grams attached to a wire. So you have a force, you have a mass of 200 grams, converting it to kgs. So you have to find the force, and you see the question is talking of force acting vertically downwards. So that is a gravitational force, because that is the type of force that acts or pulls object towards the center of the earth. So converting the 200 grams into kgs is equal to 0.2 kgs. And then we have acceleration due to gravity, which is 9.81 meters per second times 2, giving you 1.962 newtons. Then next we have a portable machine requires a force of 200 newtons to move it. How much is done if the machine is moved 20 meters, and what average power is utilized if the movement takes 25 seconds? So for a two-tied question like this, you'll have to identify the parameters, which is you have been given the force of 200 newtons, you have the distance, which is 20 meters, and you have the time, which is 25 seconds. So you'll have to recall that the first question asks of the work done. Work done equals to force times distance. So which means, and also you have to record, you just record the formulas that you know, so that from those formulas you can be able to determine which is the correct formula to take. That's what I've said. But force equals to mass times acceleration. So work done here will be equal to force times distance. Force is given 200 times distance, that is 20, giving you 4000 joules. And then you have to calculate the average power. From this aspect, we are not calculating the electrical power, so we'll have to use work done and time to find the the power. So power will be equal to work done divided by time taken, that is 4000 divided by 25, giving you 160 watts. Then another example is a mass of 1000 kgs is raised through a height of 10 meters in 20 seconds. What is the work done? The power developed. So we'll have to always, when you're given a calculative question, you always identify the parameters given, and you always list the formulas so that you can be able to determine the correct formula to choose and which is most appropriate. So you have mass, that is 1000 kgs, you have the distance in 10 meters, you have time in 20 seconds. You'll have to recall that the work done equals to force times distance. We have distance, that is, you'll have to calculate the force, because force equals to mass times acceleration. So mass is 1000, acceleration due to gravity, because it's not given here, so you'll have to introduce the acceleration due to gravity, that is 9.81 times 1000, giving you 9810 newtons. Then you'll have to equate it now, because you now have the force, equating it to the formula work done equals to force times distance. Then it will be equal to 9810 times 10, which is equal to 98,100 joules. Then calculating part B, which is the power developed. When you are given the work done, you can be able to get the power developed from work done at time in seconds, that is power equals to work done divided by time, that is 98,100 divided by 20, giving you 4,905 watts. The next is a source of EMF of 5 volts supplies a current of 3 amperes for 10 minutes. How much energy is provided in this time? So you'll have to identify the parameters given. You have a voltage of 5 volts, you have a current of 3 amperes, and you have a time of 10 minutes. So do the conversion for time, because the SI unit for time is is in seconds. So you'll have to record that the formula of energy equals to voltage times, that is the formula of energy equals to power times time. And if you have voltage and you have current, you can be able to get electrical power, which is VI, voltage times current. So that is 5 by 3, giving you 15 watts. And you can be able to now calculate the energy here by taking power multiplied by time, that is 15 multiplied by 10 minutes converted into seconds, so it gives you 9000 watts. The next, we have an electric heater consumes 1.8 megajoules when connected to a 250 volt supply for 30 minutes. Find the power rating of the heater and the current taken from the supply. So you'll also have to identify the parameters given here. The energy here is 1.8 megajoules, so you'll have to do, that is 1.8 times 10 power 6 joules, so as to remove the mega. And then you have a 240 volts, and then you have the time in seconds, convert 30 minutes into seconds. So you'll have to write the energy equals to power times time, and you have energy, and you have energy is equals to power times time, making power the subject, because you want to determine the power rating of the heater. So it means that the power will be equal to energy divided by time, and energy here is given because it's 1.8 megajoules, and you have time, that is 30 minutes. You can be able to get energy, the power, sorry. So power is 1000 watts, because it's 1.8 million divided by 1800. giving you 1,000 watts. So you'll have to recall the formula for power, because power equals to voltage times current. You can make now current the subject because you already have power and you already have voltage. So making I subject, then it means it's power over voltage. So that is 1,000 divided by 250, giving you 4 amperes. So that's how we do the calculations. So uh, here we have some practice questions that you can go practice, where it talks of in what time would a current of 1 ampere transfer a charge of 30 coulombs. So you have been given current and you have the charge, so they want you to determine the time. And then next, it's a current of 3 amperes flows for 5 minutes. What charge is transferred? You have the current, you have the time, they want us to find the charge. Then how long must a current of 0.1 ampere flow so as to transfer a charge of 30 coulombs? Then you have a force of 40 newtons accelerates a mass of 5 meters per second. Determine the mass. Determine the force acting downwards on a mass of 1500 grams suspended in a string. Then we have an electromagnetic. An electromagnetic exerts a force of 12 newtons and moves a soft iron armature through a distance of 1.5 centimeters in 40 meters per second. Find the power consumed. And then you have a mass of 500 kgs is raised to a height of 6 meters in 10 seconds. Find the work done and the power developed. Find the conductance of a resistor of resistance hiyo 10 ohms, 2 k ohms na 2 milliohms. Then a conductor has a conductance of 50 microseconds. What is its resistance? So you can be able to go practice on those questions as you apply the concepts that we've used from the basic electrical concepts and the calculations. Just a hint is that always when you're given the calculation questions is to identify all the parameters that you've been given and list down all the formulas that you can apply, so that you can be able to select the correct combination that can be able to give you one unknown step by step till you reach the final answer. So I hope this tutorial gives you a better understanding of the part A, which is of topic 1. We'll do the second part, which is the part B of electrical laws, so that you can be able to know how different laws are applied and also do the derivations, be able to state, derive, and be able to calculate. So I have a great time.